Hello. We are from Ukraine. With this episode, we are starting a series of videos about AI or artificial intelligence. We will discuss why we still cannot talk to machines like in movies. And we will start with the Holy Grail. It all started with ancient Latin texts, which did not use spaces. Usually, it is not difficult to read such texts, but sometimes it can be tricky, as with the combination sangreal. Because in those times monks were obsessed with everything saint, they read this combination as san and greal, even though greal is gibberish. So they started to use that word for a cup. That is how they came up with what is now known as the Holy Grail. But Dan Brown in the Da Vinci Code suggested a more appropriate reading: sang, blood, and real, royal, or royal blood. Just a little misunderstanding. Strangely enough, this misunderstanding illustrates problems of modern AI. Today AI is the holy grail of computer science. And we are still misled by obsession over current trends. Let me now explain how machine intelligence works. Computers are good at counting. So scientists program them to count everything. Recent achievements of AI in games can be explained by counting the number of games won after each possible move in a given position. Computers just choose a move that promises the highest chances for a win. In the case of heads or tails, the chances are 50-50. Modern AI is like a coin flip. It is no more than a guess. In some narrow applications, this approach may succeed. It only needs vast amounts of data and powerful computers. In the 70s and 80s, people did not have those. The results of AI were poor and investors lost interest. But recently it all changed. Data is there, computers perform well enough, and results in narrow applications are quite good. Most attention was paid to the successes of the GPT-3, a language model developed by the company OpenAI. To train this system, the company used almost 200 billion English words and up to $20 million. The system is capable of impressive tricks and still. As OpenAI CEO Sam Altman admitted, the GPT-3 makes silly mistakes. Most importantly, it shows a lack of understanding. Even with all that data and money, modern AI systems flip coins. My favorite English word recently is bank. Because it has meanings quite different from each other. Like financial institution versus river shore. Even mentioning a swimsuit does not help Google Translate to bend its coin in favor of the latter translation. But in this case, the game is over. In the case of language, statistical methods are no longer good. Unless one's mission is to drain a bank, not the river shore. Words do have multiple meanings, but people combine them in such ways that each word is only one interpretation consistent with other words and used grammatical structures. Sometimes ambiguity creeps in, intentionally or by chance, but the longer the text, the fewer chances it is ambiguous. Many people read books about Harry Potter, a totally fictional story. Still, we were able to imagine the whole world and interactions of the characters, learn important lessons, and improve. No one was left ambiguous about that story. What we had was only the text. One person used language to deliver the product of her imagination. All the others used language to share that product. It makes language a perfect tool for describing not only real but also imaginary worlds. Or shall we say their models? How then can we help a machine understand language and information encoded with it without distortions? First, let's simplify the world we are modeling. Yes, there are objects and actions. But we can define them in terms of properties. Objects have properties, actions change properties. Therefore, to describe the world we only need properties and time. And still, there are objects, we use different references to address them. When computers cannot disambiguate personal pronouns, we deny them intelligence. We need to somehow treat objects. Consider a property, for example, height as a scale with values. We will have not only points like 6 feet 5 inches on the scale but also ranges like doll. Both points and ranges may refer to groups of people with that particular value of height. Unique references will include several properties. It suggests using something similar to a columnar database to store individual properties. Such organization of properties also allows for fuzzy references like 6 feetish. It allows for the treatment of synonyms as referring to the same range or antonyms referring to diametrically opposite points or ranges. If any object refers to extreme points on the scale, it can be used as a metaphor. But be careful with metaphors, there is more to them than just extreme points on the scale. Actions are characterized by speed and direction of change. All the above considerations apply to them as well. So to resolve references we need to differentiate properties. Let's consider traditional approaches to NLP like the bag of words. If an algorithm based on this approach got a group of words Jack, ball, hit, it would most likely come up with a sentence Jack hit the ball, even though it may be the ending of thrown ball hit Jack. A coin flip at its best. If any approach ignores the order of words in an English sentence, it is like ignoring indentation in Python. The same applies to ignoring grammar rules and grammatical properties of words and phrases. We cannot afford to lose information if we want to make sense of a text. Pause tagging is a good first step. But many systems suggest only one pause, which they determine statistically. This will not lead us any further. Now, what about gender and number for nouns, transitive versus linking for verbs? How are you supposed to differentiate an object from a complement or ensure the subject-verb agreement? Okay, many applications out there take that information into account. Do they move on to phrases and clauses? Do they form combinations using conjunctions and treat them properly? This chatbot will do it all when all its features will be implemented. From this screenshot, the machine seems to use ternary logic. There are 3 types of answers: yes, no, and I don't know. In fact, there will be more. The machine will show different levels of uncertainty about its answers. Here you can see that it does the basic resolution of personal pronoun references. Actually, it will be able to process other male and female references. Also, it will take into account what actions that person participated in and in what role, subject or object. Implementing all that is exciting when the bot starts showing that it differentiates good from wrong. As you can see, it pays attention to properties and resolves complex references correctly. No fuzzy references or metaphors yet. Just as it was not coded to enrich internal information when learning new stuff. But it will happen one day. Maybe it will come to integration with other features: speech, vision, movement, consciousness, and world domination. Okay, joking. The application is still in development. Any suggestions or offers of cooperation are more than welcome. I only started this series of AI talks. You can help me with likes and comments. And don't forget to subscribe and push the notifications bell to be informed about upcoming videos.